A typical way to run a standalone script with Jupyter Notebook. It's not ideal, right? But usually when you have a Jupyter Notebook, the way that most researchers run it is they repeat the statements in the order that they know is right, but nobody else can figure out usually. And then if you get a good result or you get a bad result, it's usually very hard to reproduce because you run a few things, you get some result. Well, no way to repeat them or be sure that you can repeat them the same way before. So not great. Right? Cannot be shared with the team, hard to document, manual as well. Sometimes you need to run something and you need to take 5 manual steps. Okay, so preferred way to run enterprise code in development and in production. First, in development, right? You need to have an integrated development environment that can execute all tests automatically. And not only that, but it's absolutely critical that your project also has continuous integration server, such as Jenkins, Travis, TeamCity, to run tests on all new commits in selected branches. For example, it could be the develop branch or the main branch, right? So main branch is used to be the name master branch. It's not the name used anymore. So develop or main branches. Right, and the right way to set it up is to set it up so it annoys the committer, the person who made the last or the first rather breaking commit, with hourly emails until fixed, right? And usually a good idea to copy the boss so the boss knows who broke the build, right? So in a successful enterprise project, developers who break the build get bad reputation, so they know it's like a bad thing to do. Not, basically, there are some projects I've seen, you'll say, yeah, I broke the code, don't worry, I'll fix it tomorrow, right? So that should not fly in a, successful development organization. And that's what this continuous integration servers do day or night. Also, why in Python everything works so well together, what you do is that you run this test in an automated way against all of the combinations of various versions of the third-party packages that you accept, right? So in your package manager, you say that you work with a range of versions of other packages, and you test with these versions of other packages, such that no matter what the user of your package installs, what combination of third-party packages, because the requirements, it says any version after this version. That's the usual way to do it, right? So you should test with the new packages, the old packages. There are some very obscure bugs that appear, especially with math code. So you need to make sure that this continuous integration testing goes on and uses all kinds of integrations and so forth. So you always know it works well. All right, so there is a question. Let me just stop for a second. Is Windows required to use it compatible like the company policy? And what if developers use different systems to work on the same project? Okay, so well, this course is not only about compatible, but no, Windows is not required. You can use Linux. In fact, many projects use Linux because cloud runs on Linux. And with math, often you need to run math on the same operating system as you run in production to make sure that everything works correctly. It's supposed to work the same way in Windows, but it does not always for math because math is different. Basically Indian differences and so forth on CPUs as well. So yeah, I mean, you don't have to. In fact, Python is great because other than for some very specific math libraries that are prone to kind of instabilities that will produce, like machine learning is one of them, unfortunately. So some math libraries or math algorithms, they can they have bifurcations, right? So they produce different results depending on random factors. But 95 or 99% of Python code you can develop on Linux. Somebody else can develop on Windows. It will all work together, and it's actually even good because you will know that if you're developing only on Windows and nobody ever run this on Linux except the continuous integration server, which always does. Then you may overlook certain things that developer who is developing on Linux would know. So yeah, absolutely, it's no problem to use Linux. In Python, everything works, and people can use different operating systems. Not a problem at all. All right, so let me just continue. Right, so now preferred. Okay, so second thing about testing, right, is that some tests in order to run them properly, require a lot of time. For example, math tests, machine learning, right? So in order to make sure machine learning algorithm works correctly, you need to run it, and training usually takes time. So we normally deal with this, and that's a good way to do it, is using a global quality setting. So the global quality setting, and you can simply set it, basically make a class in which there is a class variable with the setting. So this quality setting controls the trade-off between how fast the test runs versus how accurate is the result. And when you set quality to 0, then it becomes the smoke test, right? So smoke test is actually, I'm not even sure what the origins of it are, but I assume you make a stove or something and see the smoke is coming out in the wrong places. But essentially, smoke test in QA is a test that you run, very quick test to just make sure that everything, the basic things work. So the key thing about smoke tests is they have to be extremely fast, because you want to be able to run the test suite in seconds, ideally, such that every time you write code, you just quickly check if you broke any tests. Right, just like you saw this 20 tests that we have, run in a second, including the setup, right? So, however, for math, for machine learning, other types of mathematical calculations, especially, sometimes, or for example, when you have tests which test database under load, right? So you try to load 1 billion of records or terabyte of data and see how long it takes or if it works. So these take longer. So if you have a quality setting, you can set it to 0 when you develop, and everything will run fast. And some tests which cannot be made fast, they will just be skipped. And in a continuous integration server will run high level of quality. And depending on how much time you have for the test and what quality you want, you can change the quality. So you can have, for example, 0 is a smoke test, 5 is the default. If you want some very precise testing, for very heavy loads, you can make it 10. If you want something better than smoke, but not the full default, make it 1 or 2. So global quality setting is the way to control testing. So we have the same tests that run different amount of time. And, for math, it usually has to do with things like how many Monte Carlo samples or how many, iterations in the machine learning optimizer. For example, so you can control it and still have faster, because if the tests are very slow, then developers will not run them when they develop. And when they find a bug, they will have to spend time finding out exactly when it happened. So testing that it can be effortlessly repeated often is very important. All right, and in production, the way that you want to run the code is command line interface, or CLI, right? It's a pretty ancient but still popular way to run code. And given new life by the cloud, because the cloud, a lot of stuff you do in the cloud is just a 70s Linux commands, right? So and approaches. So CLI is command line, right? So it's really still very much alive and used for cloud technologies. For example, AWS primarily way to interact with it is the CLI. Stateful REST, right, is when you make a REST call. Make a call to the API, Web Services API, and you pass the some parameters to the call, but it takes data from a database or service and pushes data to a database or service as stateful, or stateless when all inputs and outputs are by REST. And that type of calculation, which is stateless, is more scalable, easier to in the cloud. It's easier to implement it in a cloud, right? So it's preferable. And there's actually quite a interesting discussion there, but we should keep moving on, because that's not the primary purpose of this course.